Hey everyone, I'm building an entire first-person shooter game from scratch in the Godot engine and documenting the progress with these tutorials. The basic FPS controller project from episode 1 is available for free on GitHub, and if you would like to download all of the source files, you can get access by joining my Patreon. Let's dive in. Welcome back to another FPS tutorial. Today we're going to be adding a procedural recoil animation to our game. Now if you're working on your own setup, this is going to be pretty plug and play. You can add this to your own controller if you're doing your own thing. It's not going to be too much of an issue. For everyone else that's working along, we're going to be adding another node, a recoil node, that's going to completely handle the rotation that's going to happen when we have our procedural recoil. That recoil is going to be using a rotation method. And we're going to be essentially rotating our camera 3D node, which is going to make our view jump when we shoot by adding a little bit of rotation whenever we fire our gun. To do that, we need to add a node in between our camera controller and camera 3D node. So let's jump over to our first-person controller scene, and let's add a node 3D right here. We'll set that up above, and then we're going to take our camera 3D node, which is a parent to our weapon rig and our weapon mesh. We're going to slide that as a child to this new node, and we're going to call this new node recoil. Now we could take this script that we're creating and shove it into where we already are handling our weapon rotation. We absolutely could do that. This is more of a method of separating out that functionality into a different node, a different script. So everything's a little bit cleaner. We can communicate with other nodes a little bit cleaner, and everything's just not shoved into one script. Again, the plan is to have this node right here. Now that we have it, let's actually demonstrate this a little bit. So this controls the rotation now of our camera, our weapons, everything. And so if we rotate this recoil node, everything else is going to be rotating along with it. And that's what we want. So let's zero that out and let's create a new script. We're going to create one right here in our recoil node, create a new script, and let's save it into our scripts folder. And let's call this, well, let's be a little bit more specific, weapon recoil. All right, so we're in our new script. We're going to add some export variables. Let's start by nice clean spaces. It's adding an export variable for our recoil amount. This is going to be a vector3, and this is going to allow us to set how far that recoil node rotates whenever we fire the gun. And we can customize that, and in turn, we can have that be unique per weapon using our already created weapon system. So we have our export variable for our recoil amount, and then let's create another export variable for our snap amount. This is going to be how quickly we snap back and forth when we are rotating that node. And then one more export variable on a new line would be awesome. And this one will be the speed. This is how fast we are adding that rotation. And again, we're going to be doing this through lerps. So these are going to be our alphas for those lerps. You're going to see that in a second. Let's add a couple more variables. This one's going to be current rotation, and it will be a vector3, and one more for our target rotation, which will also be a vector3. And again, if you're unfamiliar with the that green text, and I'm putting that colon in there, that's I'm setting the type for that variable, and that's going to allow me to have some auto-complete options whenever I use and throw that variable in the script. And it's also going to be faster because the engine doesn't have to figure out, hey, what is this variable actually? So I always like to set things just nice and clean. So how this procedural recoil is going to work, we're going to be working a little bit in our process function. So every frame, we want to be adjusting the rotation of that recoil node based on whether or not we've fired our gun. So if we fire the gun, we want to add a new target rotation, and it's going to go to that target rotation gradually using our speed variable, and then eventually it's going to go back to a vector of 0, 0, 0 for that rotation, so back at center. And how we can do that is get our target rotation, and we're going to set that equal to a lerp. And it's going to be a lerp from our target rotation to our vector 3, 0. So this is back to center. And then our weight, our alpha, will be our speed value multiplied by our delta time. So what is this line going to do? Well, if we set a new target rotation, let's say we rotated 5 degrees vertically. Well, every single frame, it's going to gradually go back to center, to vector 3, 0, at the speed that we set. So that's our return lerp. Now we're going to take our current rotation and we're going to lerp that as well. So we'll do another lerp. We're going to lerp from our current rotation, and we're going to go to our target rotation. And then we'll use our snap amount times delta as our weights. All right, now that we have the current rotation, we want to actually set the rotation of that node. And we can do that by getting the basis and setting the basis equal to a quaternion from Euler, and then we're going to plug in our current rotation. So we're going to run that every frame, but we also need to get our target rotation, right? We're not actually setting that yet. So let's create a function, and this function is going to be called add recoil. And this is the function that is going to be fired when we fire our gun. And it's going to set a new target rotation. Now this target rotation is going to be set randomly because we're going to get some randomization, and that's going to be the procedural effect. We don't want it to look the same every time. We want it to be adjusted. So we're going to get our target rotation, and we're going to set this plus equal to, and we're going to add to our target rotation. So why not just equal? Well, if we are already under a recoil, we want to add to that rotation, right? So the recoil gets to be more. So we're doing a plus equals. We're going to set that equal to a vector 3 that we're going to compile here. And it's going to be using our recoil amount vector 3 with some randomization. So for our vector 3, we're going to use this recoil amount export variable that we set. And we're going to get a random value between the negative value that we set and the positive version of that value that we set. And I'll show you how that's going to work. So for our vector 3, we're going to create one with an x, y, and a z. So we take this function, the random f, which is float, and a range. And that range is going to be our recoil amount for our x, negative, to the positive of that recoil amount. So if I set over here our recoil amount to 1, then it's going to pick a float between -1 and 1 for that x rotation. And we want to do that for every single value in our vector. So we just can copy and paste that. Instead of that x, we'll use our y. I missed an x there. Let's add that in. And then we'll add our y, and we'll do the same for our z. All right, so there we go. So make sure you've got your random f range function, and then between the negative value of that x, the positive value of that x. So when we set that, it's going to give us a completely random rotation every time we fire our gun. And that's it. That's the recoil code. Now, the issue that we have to figure out is we want this to run whenever we fire the gun. And we want to actually run this add recoil function. And this is a good lesson in signals and how you communicate between nodes. The weapon is actually a child, right, of this recoil. Recoil, camera 3D, weapon rig, weapon. And this is where our script for when we are firing our gun is taking place. Now, this might be in a different place if you're working on your own setup, but for us, it's a child of this recoil. So this is the script that's going to be doing something. It's initiating that event, but it's the child. So whenever you're communicating up, that is from a child to a parent, or up the hierarchy, you want to use a signal. And we can create our own custom signals. And if you've ever gone to your node tab over here, you'll notice if you click on a node, you'll have all these pre-built signals over here. Now you can create your own. You can do that in your script. So let's create a new signal within our weapon script. And you place those signals after your class name, before your variables, and we'll call this signal weapon fired. Usually when naming signals, you do a past tense. Like you've done something has happened. So the weapon has fired, right? That's our signal. Now we've created the signal, that's it. The signal is ready to go. Now we have to emit that signal. And to do that, we go to wherever we want to emit that, and we want to emit that signal when we attack, right? So we'll go to our attack function, we'll grab our weapon fired, and then we add our emit. And that fires that signal. So now that we have that signal, we need a way to listen to it. And we're going to connect it, actually, if we go back to our recoil. Now back in our recoil, which is a parent, it's higher in the hierarchy to our weapon node, it's very easy to add a reference to our weapon node within our recoil script. So let's do that. We'll add another export variable, and we'll call this weapon. And our weapon script is using the weapon controller class. So we'll set that as the type, and that's it. An export variable is a great way to grab a node that's a child of the script, the node that you're working in. Now that we have that, we can go to our recoil node, find our weapon variable, and assign this puppy to our weapon node. And now we have a reference. And now that we have that reference, we can connect to that signal in the weapon script. When I say connect, it means whenever that signal fires, we're going to tell it to run a function within the script. So we can do that by getting that reference to our weapon, looking for the weapon fired signal that we created, and we're going to use the connect function. And then we connect that signal to our add recoil callable. Now notice that I don't have the parentheses. I'm not adding, and this is not the function. I'm just adding that reference to the callable, to the function. And that's it. That's the line that we need. Now you can, this is beyond this tutorial, but you can pass variables from a signal into the function that you're calling, which is a cool thing, but we won't get into that today. And we've connected it. That's it. We're ready to test this. So let's make sure you set some values, because if everything's 0, nothing's going to happen. So let's save everything. We'll go to our FPS controller scene and let's add some values. Let's make it just super pronounced. We'll add 1 to our X. We'll add 0.5 to the Y. To the Z, we'll keep it the same. Snap amount, we'll set that to 8, and speed we'll set to 4. And that should do it. Now, when we test, what should happen is we'll fire the gun and the camera is supposed to move. That's what's going to happen. Let's actually run it within this new scene that I set up. It's a little nicer. I like it a little bit better. 26. All right, now let's test. Okay, we've got our gun. Now when I fire, we've got our recoil. And you notice that it's quite random where it's going. Now that is the target rotation that we set up. Now we can adjust that so we can get exactly the recoil that we want. If I keep pressing, you'll see that it goes haywire. And it's also adding to the rotation that it's currently at. So let's bounce out of that and let's adjust this script a little bit. Go back to our recoil script. Okay, so here's what's managing all of that. Now you'll notice that we got some vertical up and down recoil that we didn't really need. So if you go into the FPS controller, let's see what's actually rotating what, right? So our X rotation is the up and down. And we are doing a negative value to positive value. So we're actually like going up and down. We don't want to go up and down. We just want it to go up. So let's go back to that and let's just set a, let's just set this to our X, right? It's just going to take whatever we set for our X, and that's going to be the recoil every time. Now our Y amount, if we go back here, is going to be this like left and right movement. And that's not too bad. It's probably just, it's too strong. Like we want a little bit left to right. And then our Z, if we go back to our thing, is that movement. And honestly, I don't even know if we really want that. So let's just set that to 0, which we did, which is good. So let's make this smaller. Let's do a 0.5. And then for the X, well, we've gotten rid of the negative. So let's just test out when we just set it to 1, right? Okay, that's a little bit more of the motion we're looking for. It's just, it's too much, way too much. So let's adjust the magic of procedural, right? You can adjust this however you want. You can add any value in there, and you don't have to sit there and animate or adjust an animation over and over and over again all the time. All right, let's set that to 0.15 and let's test that out. Yeah, that's a little bit better. I like that. And you can set that to however strong you want. You can adjust it so it's really a big recoil. You can make it recoil left and right a lot more. I know it looks a little bit ugly that the gun's not doing anything when we shoot. And we'll adjust that in the next video. And in fact, we're going to use the same technique because it works just as well. All right, guys, if this tutorial was helpful, consider a like and subscribe to the channel as we're going to be covering a lot more. Thanks to all of my patrons who keep this series going. You too can get access to the project source files by joining my Patreon. You can download everything there, and you'll also get early access to my videos and sneak peeks at future tutorials. Thanks for watching, and as always, keep creating.